Welcome back to the Sleep Labs tonight. We're exploring the universe through its quietest, gentlest, most sleep-inducing truths. 100 facts that remind us just how vast, how strange, and how beautifully indifferent the cosmos really is. These aren't the dramatic facts, not the exploding stars or the colliding galaxies. These are the slow facts, the patient ones, the kind that unfold over billions of years while nothing and everything happens at once. So settle in, get comfortable, and let's drift through the universe together, one fact at a time. Fact 1. The speed of light is slow. We're taught that light is fast, and it is by human standards. But on a cosmic scale, light is almost painfully slow. It takes 8 minutes for sunlight to reach Earth. That means when you feel warmth on your face, you're experiencing the sun as it was 8 minutes ago. Look at the nearest star beyond our sun, Proxima Centauri, and you're seeing it as it was 4 years ago. The Andromeda Galaxy, 2.5 million years ago. Light has been traveling toward us since before humans existed, and it's only just now arriving at your eyes. The universe is so large that even at light speed, information moves like a message in a bottle across an endless ocean. When you look up at the night sky, you're not seeing the universe as it is. You're seeing its history laid out in layers. Each star a different moment in time, all arriving together in this one quiet instant. Fact 2. Most of the universe is empty when we think of space. We think of stars, planets, galaxies, all the things we can see. But most of the universe is nothing. Vast stretches of emptiness between galaxies, between stars, between atoms. Even within an atom, most of it is empty space. The nucleus is tiny, the electrons even smaller, and the space between them is proportionally enormous. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be grains of sand orbiting somewhere in the upper seats. Everything else, empty. And it's the same on larger scales. The space between stars is so vast that if you were floating between them, you might not see another star for years of travel. The universe is mostly nothing, holding together a few scattered pieces of something. And somehow, that nothingness allows everything to exist. Fact 3. Silence is the default. Space is silent. Completely, utterly silent. Sound needs a medium to travel through: air, water, something with molecules that can vibrate and carry the wave. In the vacuum of space, there's nothing. No air, no atmosphere, no way for sound to move. So all the explosions, the collisions, the churning surfaces of stars, they all happen in perfect silence. A supernova could detonate right in front of you, tearing apart a star in the most violent event in the universe, and you wouldn't hear a thing. The roar exists only where there's atmosphere. Everywhere else, the universe conducts its business quietly, without fanfare, without announcement. It's a reminder that most of existence isn't loud or chaotic. It's still. The drama is visual, not auditory. And in that silence, there's a kind of peace, a reminder that the universe doesn't need to shout to be extraordinary. Fact. For you are made of dead stars. This one gets said a lot, but it's worth sitting with. Every atom in your body, except for hydrogen, was forged inside a star. Carbon, oxygen, nitrogen, calcium, iron, all of it came from stellar fusion or supernova explosions. Stars spend millions or billions of years fusing lighter elements into heavier ones, building the periodic table one reaction at a time. When they die, especially the massive ones, they scatter those elements into space. Those clouds of gas eventually collapse into new stars, new planets, new life. You are literally made from the remnants of stars that died long before the sun existed. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it is recycled stardust. You're not separate from the universe. You're a continuation of it, a brief arrangement of matter that once burned in the heart of a distant sun. And when you return to the earth, those atoms will continue their journey, becoming part of something else, somewhere else, someday. Fact 5. Time moves differently depending on where you are. Einstein showed us that time isn't a constant. It bends, stretches, and slows depending on gravity and velocity. The stronger the gravitational field, the slower time moves. If you stood on the surface of a black hole's event horizon, time for you would crawl to a near stop compared to someone far away. An hour for you might be years for them. GPS, satellites orbiting Earth, experience time slightly faster than we do on the surface because they're farther from Earth's gravity. Without adjustments for relativity, your GPS would drift by miles every day. Even on Earth, time moves faster at higher altitudes. A clock on a mountain runs slightly faster than one at sea level. The difference is tiny, measured in nanoseconds, but it's real. Time isn't the same for everyone, everywhere. It's personal, local, shaped by where you are and how fast you're moving. The universe doesn't experience one universal now. It experiences countless nows, all unfolding at different rates, all equally real. Fact 6. The universe has no center. If the universe exploded outward from the Big Bang, you'd think there would be a center, a point where it all began. But there isn't. The Big Bang didn't happen at a location. It happened everywhere, all at once. Space itself expanded, carrying matter with it, and every point in the universe can claim to be the center from its own perspective. Imagine dots on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot, but no single dot is the center of the expansion. The surface itself is stretching. That's what's happening to the universe. There's no edge to find, no center to return to. Wherever you are, you're at the center of your own observable universe. It's humbling and disorienting at the same time. We're all equally central and equally adrift. Fact 7. A day on Venus is longer than a year on Venus. Venus rotates so slowly on its axis that it takes longer to complete one rotation than it does to orbit the Sun. A Venusian day lasts about 243 Earth days. A Venusian year lasts about 225 Earth days. This means if you were standing on Venus, you'd experience a sunrise, watch the sun crawl across the sky for months, see it set, spend months in darkness, and then finally see it rise again, all while the planet has already circled the sun and started another orbit. It's a strange inversion of what we take for granted. Days and years don't have to follow the rhythm we're used to. Time on other worlds plays by different rules, and Venus, with its crushing atmosphere and surface hot enough to melt lead, rotates so slowly it's almost as if the planet itself has given up on hurrying. Fact 8. There are more stars than grains of sand on Earth. It's one of those comparisons that sounds exaggerated, but it's true. Estimates suggest there are roughly 7 quintillion, 500 quadrillion grains of sand on all the beaches and deserts of Earth. That's a 7 followed by 18 zeros, and yet there are more stars in the observable universe. Current estimates put the number at around 200 billion trillion stars. That's A2 followed by 23 zeros. For every grain of sand on every beach, in every desert, under every ocean, there are thousands of stars burning in the universe. Each one a sun, many with their own planets, their own systems, their own potential for something we can't yet imagine. It's a number so large it loses meaning, but the feeling remains. We are surrounded by more light than we could ever count. Fact 9. Black holes aren't black. Despite the name, black holes aren't actually black. They don't emit light, which is why they appear black against the backdrop of space. But they're surrounded by some of the brightest phenomena in the universe. As matter spirals into a black hole, it forms an accretion disk, a swirling disk of gas and dust that heats up to millions of degrees due to friction and gravitational compression. This disk glows intensely, emitting X-rays and other high-energy radiation. Some black holes also produce jets, beams of particles and energy that shoot out from the poles at nearly the speed of light, stretching for thousands of light years. These jets can outshine entire galaxies. So while the black hole itself is invisible, the space around it is anything but. It's one of the most luminous, violent, and active regions in the cosmos. The darkness at the center is real, but it's framed by light. Fact 10. The universe is getting colder. The universe started hot, unimaginably hot. In the first moments after the Big Bang, temperatures were so high that matter as we know it couldn't exist. But as the universe expanded, it cooled, and it's still cooling. The cosmic microwave background radiation, the afterglow of the Big Bang, currently measures about -270 degrees Celsius, just a few degrees above absolute zero. As the universe continues to expand, that temperature will keep dropping. Eventually, in the far future, the universe will reach a state called heat death, where all energy is evenly distributed. No stars are left burning, and the temperature approaches absolute zero everywhere. It will be cold, dark, and still. Nothing will happen because there will be no energy left to make anything happen. It's the ultimate quiet, the final stillness, the end of all process and change. For now, we live in a universe that still has warmth, still has stars, still has life. But the cold is coming, slowly, inevitably, like a winter that never ends. Fact 11. Neutron stars are incredibly dense. Neutron stars are the collapsed cores of massive stars that exploded as supernovas. They're about 20 kilometers across, roughly the size of a city, but they contain more mass than our Sun. The density is almost incomprehensible. A teaspoon of neutron star material would weigh about 1 billion tons. That's roughly the weight of Mount Everest compressed into something you could hold in your hand. If your hand could somehow withstand the pressure, the gravity is so intense that the surface is perfectly smooth. Any irregularity, even a bump a few millimeters high, would be crushed flat by the immense gravitational field. Light bends around them, time slows near them, and if you could somehow stand on one, you'd be flattened instantly into a layer of atoms less than a millimeter thick. They're remnants of stellar death, spinning relics that pulse with radiation, quiet in their way, but holding within them the memory of unimaginable violence. Fact 12. The Milky Way will collide with Andromeda in about 4 billion years. Our galaxy will collide with the Andromeda galaxy. It's already on its way, hurtling toward us at about 110 kilometers per second. When the collision happens, it won't be violent in the way we imagine. Stars are so far apart that most will simply pass by each other without ever touching. But the gravitational interactions will distort both galaxies, pulling out long streams of stars, triggering bursts of star formation as gas clouds collide, and eventually merging the two into a single, larger galaxy. Our solar system will likely survive, though it might be flung into a different part of the new galaxy or even ejected entirely into intergalactic space. By then, the Sun will be nearing the end of its life, and Earth, if it still exists, will be uninhabitable. But the stars will keep shining, rearranged into new patterns, and the universe will continue, indifferent to the reshuffling of its pieces. Fact 13. There are planets made of diamonds, some exoplanets. Planets orbiting stars other than our Sun are thought to be made largely of carbon. Under the right conditions of temperature and pressure, that carbon crystallizes into diamond. These planets aren't just covered in diamond. They're diamond all the way through, massive glittering spheres floating in space. One such planet, 55 Concrete E, orbits a star about 40 light-years away. It's about twice the size of Earth and may have a surface composed of graphite and diamond. The temperatures there are extreme, around 2000 degrees Celsius, far too hot for life as we know it. But it's a reminder that planets come in varieties we never imagined. Not just rocky or gaseous, but crystalline, metallic, molten, frozen. Each one a different experiment in physics and chemistry, shaped by the star it orbits and the materials that were available when it formed. The universe is stranger and more varied than our small sample of 8 planets would suggest. Fact 14. Light takes thousands of years to leave the Sun when a photon, a particle of light, is created in the core of the Sun through nuclear fusion. It doesn't immediately shoot out into space. The core is incredibly dense, packed with particles, and the photon bounces around, colliding with atoms, getting absorbed and re-emitted, traveling in random directions. This process is called a random walk, and it's slow, very slow. Estimates suggest it takes anywhere from 10,000 to 100,000 years for a photon to make its way from the Sun's core to the surface. Only then, once it escapes the Sun's outer layers, does it travel freely through space at the speed of light, reaching Earth in just 8 minutes. So the light warming your face right now was created deep inside the Sun long before recorded history began. Its ancient light finally free after millennia of wandering in darkness, now arriving to brighten your day. Fact 15. Saturn would float in water. You could find a bathtub large enough Saturn would float. It's the least dense planet in our solar system, with an average density lower than water. Saturn is made mostly of hydrogen and helium, the lightest elements, and its immense size is due to the thick atmosphere and layers of gas that make up most of its volume. Beneath those layers, there may be a small rocky core, but most of Saturn is just gas, loosely held together by gravity. The result is a planet so light for its size that it would bob on the surface of an ocean. Of course, There's no ocean large enough, and Saturn's gravity would distort any water around it. But the image is charming. A giant ringed planet floating gently, serene and absurd. A reminder that not everything massive is heavy, and not everything in space follows the rules we expect. Fact 16. The universe may be infinite, we can only see a portion of the universe. The observable universe, which extends about 46 billion light-years in every direction, that's the limit of how far light has been able to travel since the Big Bang. But the universe itself may be much larger. It might even be infinite. If space is flat, as current measurements suggest, and if it extends forever, then there's no edge, no boundary, no end. Just more galaxies, more stars, more space, going on forever. And if the universe is infinite, then everything that can happen has happened somewhere. There are infinite copies of you living slightly different lives, making different choices. There are infinite Earths, infinite solar systems, infinite galaxies. Every possibility, every variation exists somewhere in the endless expanse. It's a concept that breaks the mind, but it's consistent with the data. We may never know for certain because we can only see so far, but the universe doesn't care about our certainty. It simply is, whether finite or infinite, contained or endless. Fact 17. Space smells like. Metal and burnt steak astronauts who have performed spacewalks report that space has a smell. Not that they can smell it while outside, their suits are sealed. But when they return to the airlock and remove their helmets, they notice a distinct odor clinging to their suits and equipment. Most describe it as metallic, like welding fumes or burnt metal. Others compare it to the smell of seared steak or gunpowder. The exact cause isn't fully understood, but it's likely due to high-energy particles, cosmic rays, and solar wind, interacting with the materials of the spacesuit and creating volatile compounds. These compounds then sublimate or outgas when brought into the spacecraft's atmosphere, releasing the smell. It's a small, strange detail, the fact that the vacuum of space, silent and invisible, leaves behind a scent. A reminder that even in the emptiness, there are interactions happening at the molecular level, invisible processes that only reveal themselves in the smallest, most human ways. Fact 18. You are traveling through space right now, even if you're sitting still. You're moving incredibly fast through space. Earth rotates on its axis at about 1,670 kilometers per hour at the equator. It orbits the Sun at about 107,000 kilometers per hour. The Sun orbits the center of the Milky Way at about 790,000 kilometers per hour. And the Milky Way itself is moving through space, pulled by the gravity of nearby galaxy clusters at about 2 million kilometers per hour. Add it all up, and you're hurtling through the universe at speeds that would make any spacecraft jealous. But you don't feel it. There's no wind, no sense of motion, because everything around you is moving at the same speed. The air, the ground, the trees, all of it carried along together. Motion is relative, and from your perspective, you're perfectly still. But zoom out, and you're a passenger on a planet, spinning and orbiting and careening through the cosmos, never stopping, never slowing, always in motion. Fact 19. The moon is drifting away from Earth. Every year, the moon moves about 3.8 centimeters farther from Earth. It's a slow process, caused by tidal interactions between the two bodies. The Earth's rotation creates tidal bulges in the oceans, and as the Earth spins, those bulges pull slightly ahead of the Moon. The gravitational interaction transfers energy from Earth's rotation to the Moon's orbit, causing the Moon to slowly spiral outward. Billions of years ago, the Moon was much closer, and Earth's days were much shorter. As the Moon drifts away, Earth's rotation slows down, making our days gradually longer. In the distant future, if nothing else intervenes, the Moon will be so far away that it will appear much smaller in the sky, and total solar eclipses will no longer be possible. Eventually, the Earth and Moon will become tidally locked, always showing the same face to each other, rotating in perfect synchronization. But that's billions of years away. For now, the Moon still rises and sets, still pulls the tides, still lights the night, drifting slowly, almost imperceptibly, toward a future we'll never see. Fact 20. There is a giant cloud of alcohol in space near the center of our galaxy. There's a massive cloud of methanol and ethanol, the same type of alcohol found in alcoholic beverages. It's called Sagittarius B2, and it contains enough ethanol to fill 400 trillion pints of beer. The cloud is a stellar nursery, a region where new stars are forming, and the alcohol is a byproduct of complex organic chemistry happening in space. Molecules form when atoms collide in the cold, dense regions of these clouds, building up over millions of years. Methanol and ethanol are relatively simple organic molecules, and they're common in space, found in comets, asteroids, and interstellar clouds throughout the galaxy. It's not drinkable, of course. It's mixed with all sorts of other chemicals, and it exists at temperatures far below freezing. But it's a reminder that the universe is doing chemistry all the time, building molecules, experimenting with combinations, creating the raw materials for complexity. And sometimes, just by chance, it makes something familiar, floating out there in the dark. Fact 21. Olympus Mons is the largest volcano in the solar system on Mars. There is a volcano so large it dwarfs anything on Earth. Olympus Mons rises about 25 kilometers above the surrounding plains, nearly 3 times the height of Mount Everest. Its base is roughly the size of the entire state of Arizona, and its caldera, the collapsed crater at the summit, is wide enough to swallow a small city. It's a shield volcano, similar in shape to the volcanoes in Hawaii, but on a scale that's hard to comprehend. The slopes are gentle, only a few degrees, so if you were standing on the side of Olympus Mons, you might not even realize you were on a mountain. The curvature of Mars would hide the summit from view. It's been dormant for millions of years, possibly longer, and it may never erupt again. But it stands there, a monument to Mars' volcanic past, a reminder that other worlds have their own geology, their own mountains, their own slow processes of creation and decay. And some of them, like Olympus Mons, are larger than anything we've ever known. Fact 22. Time began with the universe before the Big Bang. There was no time. Time itself is a property of the universe, woven into the fabric of space. When the universe began, so did time. This means asking what happened before the Big Bang is a bit like asking what's north of the North Pole. The question doesn't make sense because there's no before. Time started at that moment, and everything that happened after is measured from that point. It's difficult to wrap your mind around because we experience time as something that flows, something that always was and always will be. But according to our current understanding, time had a beginning. And if the universe ever ends, if it collapses back into a singularity or expands into infinite cold and darkness, time might end too. Or it might continue forever, ticking away in an empty universe with nothing left to measure. Either way, time isn't what we thought it was. It's not a river we're floating down. It's part of the structure of reality itself, and like everything else, it had to start somewhere. Fact 23. We are made of quantum uncertainty, the smallest scales. The quantum scale, particles don't have definite positions or velocities until they're measured. They exist in a state of probability, a cloud of possible locations and states, all overlapping. This is called quantum superposition. An electron doesn't orbit an atom like a planet orbits a star. It exists as a probability cloud, more likely to be in some places than others, but never in one definite spot until something interacts with it. This uncertainty isn't a limitation of our tools or our knowledge. It's a fundamental property of reality, and it applies to everything, including you. Every atom in your body, every electron, every particle is a little bit uncertain, a little bit probabilistic. For large objects, these uncertainties average out, and the world appears solid and predictable. But at the core, reality is fuzzy. It's a strange, unsettling fact, but it's also what allows chemistry to work, what allows atoms to bond and molecules to form. Without quantum uncertainty, matter as we know it couldn't exist. And neither could we. Fact 24. There are rogue planets wandering the galaxy. Not all planets orbit stars. Some drift through space alone, untethered, traveling through the darkness between star systems. These are called rogue planets, and they were likely ejected from their original solar systems by gravitational interactions, flung out into interstellar space by the pull of larger planets or passing stars. Once ejected, they travel alone, no longer warmed by a sun, their surfaces frozen and dark. Some may still have internal heat from their formation or from radioactive decay, enough to maintain subsurface oceans beneath thick layers of ice. In theory, life could exist on these planets, huddled around hydrothermal vents in deep oceans, never seen a star. Estimates suggest there may be billions of rogue planets in our galaxy, possibly more rogue planets than stars. They're incredibly difficult to detect because they don't reflect light and they don't emit much heat. But they're out there, wandering silently. Orphaned worlds adrift in the void, reminders that not everything in the universe has a home. Fact 25. The largest known structure in the universe is unimaginably big, the Hercules corona borealis. Great Wall is a massive structure made up of galaxy clusters and superclusters, spanning roughly 10 billion light-years across. To put that in perspective, light traveling at 300,000 kilometers per second would take 10 billion years to cross it. It's so large that it challenges our understanding of how structures form in the universe. According to cosmological principles, the universe should be relatively uniform at large scales, but structures like this suggest there's more complexity than we thought. It's not a solid wall, of course. It's a concentration of galaxies, connected by filaments of dark matter and gas, with vast voids in between. But from a distance, it would appear as a wall, a barrier of light stretching across a significant portion of the observable universe. It's a reminder that even when we think we understand the cosmos, it still finds ways to surprise us with its scale, its structure, and its refusal to fit neatly into our models. Fact 26. Your atoms are mostly empty space. You removed all the empty space from the atoms in your body, you'd be incredibly small. The nucleus of an atom is tiny compared to the overall size of the atom, and the electrons are even smaller. Most of what makes up an atom is just empty space. If you compressed all the matter in the human body, removing that space, you'd end up with something about the size of a grain of sand, and that grain would weigh the same as you do now. It sounds absurd, but it's true. The reason you feel solid, the reason you don't pass through walls or fall through the floor, is because of electromagnetic forces. The electrons in your atoms repel the electrons in other atoms, creating the sensation of solidity. But it's an illusion in a sense. At the fundamental level, you're mostly nothing held together by forces, a pattern of energy arranged in a specific way, and somehow that pattern is complex enough to be conscious, to wonder about itself, to look up at the stars and ask questions. Fact 27. The sun loses mass every second. The sun is constantly losing mass through two main processes. First, nuclear fusion in its core converts mass into energy, about 4 million tons every second, following Einstein's equation E equals mc squared. Second, the solar wind, a stream of charged particles flowing out from the sun, carries away additional mass. Combined, the sun loses about 4.3 million tons of mass every second. That sounds like a lot, but the sun is so massive that this loss is negligible. It would take trillions of years for the sun to lose a significant fraction of its mass this way. Still, it's happening right now. Every second, the sun becomes slightly lighter, radiating energy into space, warming planets, driving weather, sustaining life. And in doing so, it slowly converts itself into light and heat. A process that will continue for billions of years until the hydrogen fuel runs out and the sun begins its final transformation into a red giant. Fact 28. There are more possible games of chess than atoms in the universe after just a few moves in a chess game. The number of possible positions explodes. After 4 moves by each player, there are over 288 billion possible positions. After 10 moves each, the number is in the quadrillions. The total number of possible chess games, considering all the ways a game could unfold, is estimated to be around 10 to the power of 120. That's a 1 followed by 120 zeros. For comparison, the number of atoms in the observable universe is about 10 to the power of 80. Chess is a finite game with simple rules, yet it contains more complexity than all the matter in the universe. It's a reminder that complexity doesn't require size or scale. It can emerge from simple systems, from rules interacting in countless ways, creating patterns and possibilities that extend far beyond what we can ever explore. The universe is full of these kinds of systems, places where simplicity gives birth to infinite variation. Fact 29. Gravity is the weakest force for the 4 fundamental forces in nature. Gravity is by far the weakest. Electromagnetism is about 1,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000 times stronger. The strong nuclear force, which holds atomic nuclei together, is even stronger. The weak nuclear force, responsible for radioactive decay, is also stronger than gravity. You can demonstrate this easily. A small refrigerator magnet can overcome the gravitational pull of the entire Earth when it picks up a paperclip. The magnet's electromagnetic force is stronger than the gravity of a planet with a mass of 6 trillion kilograms. So why does gravity seem so dominant in our lives? Because it's always attractive, it works over infinite distances, and it adds up. The more mass you have, the stronger the gravitational pull. For everyday objects, gravity is negligible, but for planets, stars, and galaxies, it becomes the dominant force shaping the structure of the universe. It's weak, but it's persistent, patient, and it never lets go. Fact 30. The coldest place in the universe is on Earth. The coldest naturally occurring temperatures in the universe are found in the Boomerang Nebula, a cloud of gas expanding from a dying star, where temperatures drop to about 1 degree above absolute zero. But the coldest place ever recorded is actually on Earth, in a laboratory. Scientists have cooled atoms to within a billionth of a degree above absolute zero using lasers and magnetic fields. At these temperatures, matter behaves in strange ways. Atoms move incredibly slowly. Quantum effects become visible at larger scales, and substances enter exotic states like bosons, where groups of atoms act as a single quantum entity. Absolute zero, the point where all atomic motion stops, is theoretically impossible to reach, but we've gotten remarkably close. It's strange to think that the coldest temperatures in the universe, colder than the depths of intergalactic space, exist in carefully controlled environments here on our warm, living planet. We've created conditions that don't naturally exist anywhere, pushing the boundaries of cold just to see what happens. Fact 31. You can't see most of the universe. About 95% of the universe is invisible. Not because it's too far away, but because it doesn't interact with light. About 68% of the universe is dark energy, a mysterious force causing the expansion of the universe to accelerate. 27% is dark matter, an unknown substance that exerts gravitational pull but doesn't emit, absorb, or reflect light. Only about 5% of the universe is ordinary matter, the stuff we can see, the stars, planets, gas, dust, and everything made of atoms. We know dark matter and dark energy exist because of their effects. Galaxies rotate in ways that suggest there's more mass than we can see. The universe's expansion is speeding up when it should be slowing down. But we don't know what these things are made of or why they exist. We're living in a universe where most of reality is hidden from us, operating in ways we don't understand, shaping everything we see while remaining invisible. It's humbling and deeply mysterious. Fact 32. Some stars are older than the universe. This is a paradox that puzzled astronomers for years. Some stars appear to be older than the estimated age of the universe. The universe is about 13.8 billion years old, but some stars showed ages of 14 or 15 billion years. The resolution came from better measurements. The age of the universe was refined using data from the cosmic microwave background, and the methods for determining stellar ages were improved. It turned out the stars weren't older after all. But the fact that we could even arrive at such a paradox shows how difficult these measurements are. We're trying to determine the age of objects billions of light years away using indirect methods, looking at their brightness, their color, their chemical composition. Every measurement has uncertainty, and small errors can lead to big contradictions. Now the numbers align, but the episode is a reminder that our understanding of the universe is built on careful measurement and constant refinement. What seems impossible today might just be a calibration error waiting to be fixed. Fact 33. There's a supervoid that shouldn't exist. The cold spot in the cosmic microwave background is a region of space that's slightly colder than its surroundings. It's about 1.8 billion light-years across, and it corresponds to a supervoid, a vast region of space with fewer galaxies than expected. Voids exist throughout the universe, regions where matter is sparse, but the cold spot supervoid is unusually large. Some scientists suggest it might be evidence of something beyond our current understanding, perhaps a collision with another universe or a topological defect in the fabric of space. Most likely, it's just a statistical anomaly, an unlikely but not impossible fluctuation in the distribution of matter. But it's strange enough that it doesn't fit neatly into models. The universe is supposed to be relatively uniform at large scales, but the cold spot suggests there's more variation than expected. It sits there in the data, quiet and cold, a gap in the cosmos that might mean nothing or might mean everything. Fact 34. Light can be trapped in a black hole. Not even light can escape. But you don't need a black hole to trap light. Scientists have managed to slow light down to a crawl and even stop it completely by passing it through ultra-cold clouds of atoms called Bose-Einstein condensates. Normally, light travels at about 300,000 kilometers per second in a vacuum, but when it passes through certain materials, it slows down. In water, it travels at about 75% of its speed in a vacuum. In glass, even slower. In specially prepared atomic clouds, light can be slowed to less than 1 meter per second, slower than a walking pace. And by carefully manipulating the atoms, scientists can store light, capturing its information and releasing it later. It's not quite stopping light in the way we imagine, but it's close. It's another example of how flexible reality is at the quantum level. How the rules we take for granted can be bent, and how light, the fastest thing in the universe, can be tamed under the right conditions. Fact 35. The universe has no obligation to make sense. This isn't a scientific fact in the traditional sense, but it's a useful reminder. The universe doesn't operate according to human intuition. Quantum mechanics is strange, with particles existing in multiple states until observed, with entanglement linking particles across vast distances, with uncertainty built into the foundations of reality. Relativity is strange, with time bending, space warping, and the speed of light being the ultimate speed limit. Dark matter and dark energy are strange, invisible forces shaping the cosmos in ways we can barely understand. And yet, all of these strange things are real. They've been tested, measured, confirmed over and over. The universe isn't obligated to make sense to us. It simply is what it is, and our job is to observe, measure, and build models that match the data, even when those models defy common sense. The more we learn, the stranger things get, and that's okay. Strangeness isn't a flaw. It's a feature. It's what makes the universe endlessly surprising, endlessly fascinating, endlessly worth exploring. Fact 36. Jupiter protects Earth. Jupiter's massive gravity acts as a shield for the inner solar system. Its gravitational pull deflects or captures many comets and asteroids that would otherwise travel inward toward Earth. Some of these objects are flung out of the solar system entirely, while others are captured and crash into Jupiter instead. The famous comet Shoemaker-Levy 9 was broken apart by Jupiter's gravity and then slammed into the planet in 1994, leaving dark scars in the atmosphere visible from Earth. Without Jupiter, Earth would likely be hit by far more asteroids and comets, making the development of complex life more difficult. It's not a perfect shield. Some objects still get through, but Jupiter's presence has probably reduced the impact rate significantly. It's a quiet, ongoing protection, a massive planet absorbing blows that might have struck us, allowing life to flourish in relative safety. We owe a debt to Jupiter, even if we rarely think about it. Fact 37. Time travel to the future is possible. Already traveling into the future, 1 second at a time, but you can speed up that journey. According to relativity, time moves slower for objects moving at high speeds or experiencing strong gravitational fields. If you traveled in a spacecraft at near light speed for a few years and then returned to Earth, decades or even centuries could have passed on Earth while only a few years passed for you. You would have effectively traveled into the future. This is called time dilation, and it's been confirmed experimentally. Atomic clocks on fast-moving aircraft tick slightly slower than clocks on the ground. Astronauts on the International Space Station age slightly slower than people on Earth, though the difference is only a fraction of a second over months. Time travel to the past is more complicated and may be impossible, but time travel to the future is real, tested, and within the laws of physics. You just need to move very fast or spend time near something with immense gravity. The future is always waiting, and with enough speed, you can rush toward it. Fact 38. The universe is Bayesian 2001. Astronomers analyzed the light from over 200,000 galaxies to determine the average color of the universe. The result was a pale tan, which they called cosmic latte. The color comes from averaging the light emitted by all the stars and galaxies, weighted by their brightness and distance. Younger, hotter stars are blue, while older, cooler stars are red. Mix them all together across billions of galaxies, and you get a light beige. It's not the dramatic color you might expect for the universe, but it's fitting in a way. The cosmos isn't trying to be flashy. It's old, vast, and mostly indifferent. Beige feels appropriate. Of course, this is just the average. Look closely, and the universe is full of color. Nebulas glow red and blue. Stars range from deep red to brilliant white. Galaxies shine in every shade. But step back, take it all in, and the universe fades to a soft, neutral tone. The color of everything and nothing blended together. Fact 39. Water is older than the sun, the water in Earth's oceans. In your body, in every glass you drink, is older than the solar system. Water molecules form in interstellar space, in the cold clouds between stars, when hydrogen and oxygen combine. These clouds existed long before our sun was born. When the solar system formed about 4.6 billion years ago, it incorporated water that was already present in the collapsing cloud of gas and dust. Some of that water ended up on Earth, delivered by comets and asteroids during the planet's early history. So the water you drink is ancient, older than the sun, older than the planets, formed in the cold darkness between stars and carried here by chance. It's been recycled through countless processes, evaporating, raining, freezing, melting, flowing through rivers and oceans, through plants and animals, through civilizations, and now, for a moment, it's here with you. Temporary, borrowed, ancient. Fact 40. The great attractor is pulling Usawa Galaxy, along with hundreds of thousands of other galaxies, is being pulled toward something called the Great Attractor. It's a gravitational anomaly located about 200 million light-years away, hidden behind the plane of the Milky Way, making it difficult to observe directly. The Great Attractor itself seems to be part of an even larger structure called the Laniakea supercluster, a massive collection of galaxies spanning 500 million light-years. Everything in this region of space is moving toward a central gravitational focal point. We're traveling toward it at about 600 kilometers per second, carried along by the flow of galaxies. Like leaves in a current, we'll never reach it, not in any human timescale. But the pull is real, constant, shaping the motion of galaxies across a significant portion of the universe. It's a reminder that even galaxies don't stay still. Everything is moving, flowing, drawn by invisible forces across the cosmic landscape. Fact 41. You are slightly radioactive. Your body contains radioactive isotopes, potassium-40, carbon-14, and others. These isotopes decay over time, emitting radiation. It's not dangerous, the amounts are tiny, but it's measurable. Every second, about 4,000 potassium-40 atoms in your body decay, releasing a tiny bit of energy. Carbon-14, which is used in radiocarbon dating, is constantly being replenished by cosmic rays hitting the atmosphere and then absorbed by plants and animals through the food chain. When you eat, you take in small amounts of carbon-14, keeping your levels topped up. After you die, you stop taking in new carbon-14 and it begins to decay, which is how archaeologists date organic remains. But while you're alive, you're slightly radioactive, glowing faintly with the decay of unstable atoms. It's nothing to worry about. It's been this way for all of human history. You're part of the natural background radiation of the planet, a small contributor to the low hum of radioactivity that exists everywhere. Fact 42. Stars don't twinkle. The twinkling of stars is an atmospheric effect, not a property of the stars themselves. When starlight enters Earth's atmosphere, it passes through layers of air with different temperatures and densities. These layers refract or bend the light slightly, causing the star's position to shift rapidly. Our eyes perceive this as twinkling. In space, above the atmosphere, stars shine steadily, without flickering. Planets don't twinkle as much as stars do, because they're closer and appear as small disks rather than points of light. The light from different parts of the disk averages out, smoothing the atmospheric distortions. Astronomers place telescopes on mountaintops and in space, partly to avoid atmospheric distortion. The clearer the air, the steadier the stars. So when you see a star twinkling, you're not seeing the star change. You're seeing Earth's atmosphere in motion, turbulent air, shifting and bending light. A reminder that we're looking at the universe through a lens, and that lens isn't always clear. Fact 43. The Sun's surface is cooler than its corona. The surface of the Sun, the photosphere, has a temperature of about 5,500 degrees Celsius. But the corona, the outer atmosphere visible during the solar eclipse, reaches temperatures of over 1,000,000 degrees Celsius. This is called the coronal heating problem, and it's one of the unsolved mysteries of solar physics. Heat usually flows from hot to cold, so you'd expect the outer layers to be cooler than the surface. But something is heating the corona, and we're not entirely sure what. Leading theories involve magnetic fields, which are incredibly strong and complex in the Sun's atmosphere. These fields can release energy through reconnection events, small explosions that heat the surrounding gas. Another possibility is that waves of energy generated by convection currents below the surface travel upward and dissipate in the corona, depositing their energy as heat. Whatever the cause, it's a reminder that even our nearest star still holds mysteries, processes we observe but don't fully understand. Fact 44. We live inside a star's remains. The Sun and everything in our solar system formed from the remnants of previous stars. About 4.6 billion years ago, a giant molecular cloud, a vast region of gas and dust floating in space, began to collapse under its own gravity. This cloud was enriched with heavy elements, carbon, oxygen, iron, silicon elements that were forged in earlier generations of stars and scattered into space when those stars died. As the cloud collapsed, it formed a spinning disk. At the center, the Sun ignited. In the disk around it, dust grains stuck together, forming larger clumps which grew into planetesimals, then planets. Everything in our solar system, the Sun, the planets, the moons, the asteroids, comets, and us, is made from recycled star material. We're not just connected to the stars poetically, we're literally built from them. Our entire existence is a consequence of stellar death and rebirth, a cycle that's been happening for billions of years, turning gas into stars, stars into heavy elements, and heavy elements into new worlds. Fact 45. There are sounds in space. Space is a vacuum, so sound waves can't travel. But that doesn't mean there's no sound at all. It just means sound needs a different medium. In the thin gas of nebulae or in the plasma surrounding planets, pressure waves can propagate, and these are essentially sounds, though far too low in frequency for human ears. NASA has recorded these waves and converted them into audible frequencies. The result is eerie, haunting tones, the sound of plasma vibrating around planets, the hum of magnetic fields, the oscillations of gases in distant nebulae. Black holes also produce sound, in a sense. The supermassive black hole at the center of the Perseus galaxy cluster creates pressure waves in the surrounding hot gas. These waves have a frequency, and if you could hear them, they'd be the deepest note ever detected in the universe. About 57 octaves below middle C, it's been vibrating for hundreds of millions of years, a low hum echoing through the cosmos. Inaudible but real. Fact 46. You share your birthday with 10 million people. There are about 8 billion people on Earth. Divide that by 365 days, and you get roughly 22 million people born on any given day. So every day, including today, about 22 million people are celebrating their birthday. It's a strange thought that your birthday, which feels personal and unique, is shared by millions of others. Across the world, right now, people are blowing out candles, receiving gifts, marking another year. And not just humans. Countless animals, plants, microbes, all came into existence on this day in different years. The universe doesn't mark time the way we do, but we do, and in doing so, we create these little intersections, moments where our personal timelines align with millions of others. It's a reminder that you're not alone, even in something as individual as a birthday. You're part of a pattern, one of many, all moving through time together. Fact 47. Mars has blue sunsets on Earth. Sunsets are red and orange because the atmosphere scatters blue light more than red light. When the sun is low on the horizon, its light passes through more atmosphere, scattering away most of the blue and leaving the red and orange hues. On Mars, it's the opposite. The Martian atmosphere is thin and filled with fine dust particles. These particles scatter red light more effectively than blue light. So when the sun sets on Mars, the area around the sun appears blue, while the rest of the sky takes on a reddish hue. It's a subtle, beautiful inversion of what we're used to. Rovers on Mars have captured images of these blue sunsets, quiet moments at the end of a Martian day, the sun dipping below the horizon, casting a soft blue glow over the rust-colored landscape. It's a reminder that other worlds have their own beauty, their own atmospheres, their own ways of painting the sky. Fact 48. The universe could end at any moment. One of the hypothetical ways the universe could end is through a process called vacuum decay. The idea is that the current state of the universe, the vacuum of space, might not be the lowest energy state. It might be a false vacuum, stable for now, but not truly stable. If that's the case, a quantum fluctuation could trigger a transition to the true vacuum. This would create a bubble of true vacuum that expands at the speed of light, destroying everything it touches. The laws of physics inside the bubble would be different. Atoms would fall apart, and everything would cease to exist. The scary part is that we wouldn't see it coming. It would travel at light speed, so there'd be no warning. One moment, everything is fine. The next, nothing. But before you panic, this is purely hypothetical. We don't know if the vacuum is false or true, and even if it is false, the probability of decay might be so low that it won't happen for trillions upon trillions of years, if ever. Still, it's a reminder that the universe's stability isn't guaranteed. We live in a cosmos that might be more fragile than it appears. Fact 49. There are no straight lines in space. Everything in the universe follows curved paths because of gravity. Planets orbit stars in ellipses. Stars orbit the centers of galaxies. Galaxies move in response to the gravitational pull of other galaxies. Even light bends when it passes near massive objects. This is because gravity isn't a force pulling on objects. It's a curvature of space-time. Massive objects warp the fabric of space around them, and everything, including light, follows the curves. This is the central insight of Einstein's general relativity. What we perceive as gravity is actually the geometry of space-time itself. So when you see a planet orbiting a star, it's not being pulled by a force. It's following the straightest possible path through curved space-time. In a sense, it's still moving in a straight line. It's just that space itself is bent. There are no truly straight lines in the universe. Everything curves, everything bends, everything follows the shape of space-time, which is shaped by the matter and energy within it. Fact 50. Honey never spoils. Archaeologists have found pots of honey in ancient Egyptian tombs that are over 3,000 years old and still perfectly edible. Honey has an incredibly long shelf life because of its unique chemistry. It's very low in moisture and highly acidic, with a pH between 3 and 4.5. Most bacteria and microorganisms can't survive in such an environment. Additionally, bees add an enzyme called glucose oxidase when they make honey. This enzyme breaks down into hydrogen peroxide, a mild antiseptic, which further prevents microbial growth. As long as honey is stored in a sealed container, it can last indefinitely. It might crystallize over time, but it's still good. You can liquefy it again by gently heating it. Honey is one of the few foods that never spoils, a small miracle of chemistry and biology. It's been sustaining humans for thousands of years, and jars made today could, in theory, still be good thousands of years from now. It's a sweet, sticky form of immortality. Fact 51. Your eyes can detect a single photon. The human eye is remarkably sensitive. Studies suggest that under ideal conditions, in complete darkness, after allowing your eyes to fully adjust, you can detect as few as a single photon of light. A photon is the smallest possible unit of light, and the fact that our biological senses can pick up something that small is extraordinary. Of course, your brain filters out a lot of noise, so you wouldn't consciously perceive every single photon that hits your retina. But the rods in your eyes, the cells responsible for low-light vision, are sensitive enough to respond to individual photons. This sensitivity evolved over millions of years, allowing our ancestors to see in near darkness, to spot predators, navigate at night, find food. It's a reminder that evolution fine-tunes biology to incredible precision, creating systems that operate at the very edge of physical limits. Your eyes are quantum detectors, responding to the smallest packets of light, connecting you to the universe one photon at a time. Fact 52. Time feels different in space. Astronauts often report that their perception of time changes in space. Days and nights on the International Space Station occur every 90 minutes because the station orbits Earth so quickly. The sun rises and sets 16 times in a 24-hour period. This disrupts the body's natural circadian rhythm, the internal clock that regulates sleep, wakefulness, and other biological processes. Many astronauts experience difficulty sleeping, and they describe time as feeling both faster and slower, depending on the context. Tasks take longer because everything is more difficult in microgravity, but the days blur together because there's no natural day-night cycle to anchor their perception. It's disorienting, a reminder that our sense of time is deeply tied to the rhythms of Earth. When you remove those rhythms, time becomes slippery, less intuitive. Astronauts adapt using artificial schedules and light cues. But the experience of time in space is fundamentally different from time on Earth, even before you account for relativistic effects. Fact 53. The moon has moonquakes just like Earth has earthquakes. The moon has moonquakes. They're not caused by tectonic plates. The moon doesn't have active plate tectonics, but by other processes. Some moonquakes are caused by tidal forces from Earth's gravity, which stretches and compresses the moon as it orbits. Others are caused by meteorite impacts or by the cooling and contraction of the moon's interior. Deep moonquakes occur about 700 kilometers below the surface and can last for hours. Much longer than earthquakes on Earth, shallow moonquakes are rarer but more intense, sometimes reaching magnitudes of 5 on the Richter scale. The moon's lack of atmosphere and water means seismic waves travel farther and last longer than on Earth. When Apollo astronauts placed seismometers on the moon, they detected thousands of moonquakes over several years. The moon is not a dead rock. It's still active, still changing, still shaking, a reminder that even small, airless worlds have geologies of their own. Fact 54. Bananas are radioactive. Bananas contain potassium, and a small fraction of that potassium is the radioactive isotope potassium-40. Eating a banana exposes you to about 0.1 microsieverts of radiation, a tiny amount. This has led to the creation of an informal unit of radiation measurement called the banana equivalent dose. It's used to put radiation exposure into perspective. For example, a chest X-ray is about 200 banana equivalent doses. A flight from New York to Los Angeles is about 400. Living near a nuclear power plant for a year is about 3 bananas worth of extra radiation. The point is that radiation is everywhere. In the food we eat, the air we breathe, the ground we walk on. It's natural, and in small amounts, it's harmless. Bananas are perfectly safe to eat. The radiation they emit is negligible compared to the natural background radiation we're exposed to every day. But it's a fun fact, a reminder that radioactivity isn't just something in nuclear reactors or distant stars. It's in your kitchen, sitting in a fruit bowl, glowing faintly with the decay of potassium-40. Fact 55. We don't know what most things are made of. We can see atoms with powerful microscopes. We can smash particles together in accelerators to study their properties. But when we try to understand what particles are fundamentally made of, things get murky. Electrons, for example, are considered elementary particles, meaning they're not made of anything smaller. They're point-like, with no internal structure as far as we can tell. But what does that mean? What is an electron, really? It's a bundle of properties: mass, charge, spin. But is it a thing, or just a mathematical description? Quarks, the particles that make up protons and neutrons, also seem to be elementary, but they're never found alone. They're always bound together, and the forces holding them are so strong that trying to separate them just creates more quarks. The more we look, the stranger it gets. Particles are waves, waves are particles, and at the deepest level, everything might just be vibrations in quantum fields. We have models that work, equations that predict, but the question of what things are made of at the most fundamental level remains open. We know how things behave. We're less sure about what they are. Fact 56. The longest living organisms are older than civilizations. Some organisms have been alive for thousands of years, far longer than any human civilization. In California, there's a bristlecone pine tree named Methuselah that's about 4,800 years old. It was already ancient when the pyramids were built. In Utah, a colony of quaking aspen trees called Pando shares a single root system and is estimated to be around 80,000 years old. though individual stems die and regrow. In the ocean, some glass sponges are thought to be over 10,000 years old, sitting on the sea floor, filtering water, growing slowly. These organisms have witnessed the entire span of recorded human history and more. They were here before writing, before agriculture, before cities, and they'll likely outlive us. They don't hurry, they don't build, they simply exist patiently, year after year, century after century, enduring through climate shifts, wars, extinctions, indifferent to the rise and fall of empires. It's humbling, a reminder that time operates on many scales, and some lives unfold at a pace we can barely imagine. Fact 57. Your body replaces itself. Most of the cells in your body are constantly dying and being replaced. Red blood cells last about 4 months. Skin cells turn over every few weeks. The cells lining your stomach are replaced every few days because the stomach's acidic environment is so harsh. Even bone cells are replaced, though more slowly, over the course of about 10 years. Some cells, like neurons in your brain, are longer lasting. Many of the neurons you were born with are still with you, though they're constantly repairing and maintaining themselves. But overall, your body is more like a river than a statue. The form stays the same, but the substance is always flowing, always renewing. In a sense, you're not the same person you were 7 years ago, at least not physically. The atoms that made up your body then are mostly gone, replaced by new atoms from the food you've eaten, the water you've drunk, the air you've breathed, and yet the pattern persists. You remain you, even as the matter changes. It's a beautiful contradiction, continuity through change. Identity through transformation. Fact 58. The center of the Milky Way smells like raspberries and rummin, the vast cloud of gas and dust near the center of our galaxy. Scientists have detected ethyl format, an organic compound that gives raspberries their smell and contributes to the taste of rum. It's not concentrated enough for you to smell if you were somehow there, and you wouldn't survive the trip anyway, but it's a delightful detail. Space is full of organic molecules, the building blocks of life as we know it. Amino acids, sugars, alcohols, all drifting in clouds between the stars. These molecules form through chemical reactions driven by ultraviolet light from stars and cosmic rays. Over time, they become part of new star systems, new planets, potentially new life. The fact that the center of our galaxy contains something that smells like fruit is a reminder that chemistry is universal. The same processes that happen in a kitchen, fermentation, oxidation, molecular bonding, also happen in space on an unimaginable scale. The universe is a vast laboratory, constantly experimenting, sometimes producing results that are strangely familiar. Fact 59. Silence has a sound if you sit in an anechoic chamber, a room designed to absorb all sound reflections. You'll eventually hear things you don't normally notice. Your heartbeat, the movement of your joints, the sound of your blood flowing through your veins. Some people report hearing a high-pitched ringing, which is often tinnitus, a phenomenon where the brain generates sound in the absence of external noise. In deep silence, the lack of input makes your auditory system hypersensitive, amplifying internal sounds. It's unsettling for many people. Humans aren't built for true silence. We're used to ambient noise, the hum of electronics, distant traffic, wind, birds. When all of that is stripped away, the silence itself becomes loud, oppressive even. Most people can't stay in anechoic chambers for more than an hour. The quietest room in the world, at Microsoft's headquarters, has a background noise level of negative 20.6 decibels, quieter than human breathing. Standing in it, you become the loudest thing in the room. Silence, it turns out, isn't empty. It's full of you. Fact 60. Some galaxies are cannibals. Galaxies grow by consuming other galaxies. When two galaxies get close, their gravitational interaction can pull them together, and over millions of years they merge. The smaller galaxy is torn apart, its stars scattered and absorbed into the larger galaxy. The Milky Way is currently in the process of consuming several smaller galaxies, including the Sagittarius dwarf elliptical galaxy, which is being stretched and pulled apart by our galaxy's gravity. In a few billion years, when the Milky Way collides with Andromeda, both galaxies will merge into a single, larger galaxy, sometimes nicknamed Milky Way. This process of galactic cannibalism has been happening throughout cosmic history. Most large galaxies, including ours, are the result of many smaller galaxies merging over time. It's a slow, violent process, but also strangely peaceful. The stars themselves rarely collide. They're too far apart. Instead, they just change neighborhoods, finding themselves in a new galaxy, orbiting a new center, part of a new structure. The universe builds complexity through consumption, creating larger and larger systems from the fragments of smaller ones. Fact 61. You blink more than you think on average. A person blinks about 15 to 20 times per minute. That's up to 28,800 times per day. Each blink lasts about 1/10 of a second, which means you spend roughly 10% of your waking hours with your eyes closed. Your brain edits out these moments of darkness, creating the illusion of continuous vision. This is called saccadic masking. Your brain knows you're about to blink and suppresses the visual input during that time, preventing you from experiencing a constant flicker of darkness. It's a seamless edit, happening thousands of times a day without you noticing. Blinking serves multiple purposes. It spreads tears across the surface of your eyes, keeping them moist. It clears away dust and debris, and it gives your eyes a brief rest. You blink more when you're tired, stressed, or thinking hard, and less when you're focused on something like reading or watching a screen. It's an automatic process, but it's also tied to your mental state, a small window into how your brain is managing attention and fatigue. Fact 62. The universe has a speed limit. Nothing can travel faster than light in a vacuum. This isn't just a practical limitation. It's a fundamental law of the universe. Light travels at about 299,792 kilometers per second, and that speed is absolute. It's the same for everyone, regardless of how fast they're moving. This leads to all sorts of strange effects. As you approach the speed of light, time slows down for you relative to others. Your mass increases, requiring more and more energy to accelerate further. At the speed of light, time stops entirely and mass becomes infinite. This makes it impossible for anything with mass to reach light speed. Only massless particles, like photons, can travel at that speed. This speed limit shapes the structure of the universe. It determines how quickly information can travel, how galaxies are distributed, how we perceive causality. It's not a barrier imposed by technology. It's woven into the fabric of space-time itself. And it means that the universe will always have distant regions we can never reach, information we can never access, boundaries we can never cross. Fact 63. Mountains are neutron. Stars are tiny neutron. Stars have incredibly strong gravity, and any irregularities on their surface are crushed flat. A mountain on a neutron star would be only a few millimeters high, despite the star's diameter of about 20 kilometers. Anything taller would collapse under its own weight. The surface gravity is about 200 billion times stronger than Earth's. If you could somehow stand on a neutron star, you'd be flattened into a layer of atoms less than a millimeter thick. The intense gravity also affects the star's shape. Neutron stars spin extremely fast, sometimes hundreds of times per second, and this rotation creates a slight bulge at the equator. But even that bulge is tiny, just a few centimeters. The surface is smooth, hard, and unimaginably dense. It's made of neutron degenerate matter, a state where electrons and protons have been crushed together into neutrons, packed so tightly that a cubic centimeter weighs as much as a mountain. Neutron stars are extreme objects, pushing the limits of physics, existing in conditions we can barely comprehend. Fact 64. There are invisible galaxies. Some galaxies emit almost no visible light. These are called dark galaxies, and they're made mostly of gas and dark matter, with very few stars. They're incredibly difficult to detect because they don't shine. Astronomers find them by looking for their gravitational effects on nearby galaxies, or by detecting the faint glow of hydrogen gas within them. Dark galaxies may be common in the universe, outnumbering visible galaxies, but we don't know for sure because they're so hard to see. They're ghosts, vast structures floating in space, shaping the cosmos through gravity alone. Their existence suggests that our census of galaxies is incomplete, that much of the universe's matter is hidden, not just in the form of dark matter, but in entire galaxies that never lit up. They're out there, silent and dark, drifting through the void, contributing to the universe's mass and structure, but invisible to our eyes and most of our instruments. It's a reminder that what we see is only a fraction of what exists. Fact 65. Time is relative to gravity. Clocks run slower in stronger gravitational fields. This is a prediction of general relativity, and it's been confirmed many times. A clock at sea level ticks slightly slower than a clock on a mountaintop because sea level is closer to Earth's center of mass and experiences stronger gravity. The difference is tiny, measured in nanoseconds, but it's real. GPS satellites have to account for this effect. They orbit high above Earth, where gravity is weaker, so their clocks run slightly faster than clocks on the ground. If this wasn't corrected, GPS would be off by kilometers within a day. Near a black hole, the effect is extreme. Time slows so much that if you watched someone fall toward a black hole, you'd see them slow down, redden, and eventually freeze at the event horizon, never quite crossing it from your perspective. But from their perspective, they'd fall right through, experiencing no pause. Time is not a universal constant. It's local, shaped by gravity, different for everyone depending on where they are. It's one of the strangest and most confirmed predictions of relativity. Fact 66. The Earth hums. The Earth produces a constant low-frequency vibration, a hum that's too low for humans to hear. It's caused by ocean waves, wind, atmospheric pressure changes, and other natural processes. Seismometers can detect it, a background noise that never stops. The frequency is around 2 to 7 MHz, far below the range of human hearing, which starts at about 20 Hz. But it's always there, a deep resonance, the planet vibrating like a bell struck long ago. Scientists study this hum to learn about Earth's interior structure. The way the vibrations travel through the planet reveals information about the density and composition of the mantle and core. It's a tool for seeing inside the Earth without drilling. The hum varies slightly depending on seasons, weather patterns, and ocean conditions. It's louder in winter when storms are more intense. The Earth is not silent. It's singing a low, steady note. The sound of a planet alive with motion, energy, and change. Fact 67. You are never touching anything when you touch something. You're not actually making contact. The electrons in the atoms of your hand repel the electrons in the atoms of the object. And this electromagnetic repulsion creates the sensation of solidity. But the atoms never touch. There's always a tiny gap maintained by forces. You're hovering above everything you think you're touching, separated by a distance so small it's imperceptible, but real nonetheless. This is true for everything. You're not sitting on a chair. You're floating just above it, held up by electromagnetic forces. You've never truly touched another person. You've never touched the ground. Every sensation of contact is an illusion created by forces pushing back against you. At the atomic level, the universe is mostly empty space, and the things we call solid are just regions where forces are strong enough to resist being pushed through. It's a strange thought that all of physical experience is mediated by forces, not by matter. You live in a world of fields and repulsions, never quite connecting, always hovering, separated by the smallest distances imaginable. Fact 68. Rainbows are personal. No, to people see the same rainbow. A rainbow is formed by sunlight refracting through water droplets in the air, and the angle at which the light reaches your eyes determines what you see. The rainbow exists at a specific angle from your perspective, about 42 degrees from the anti-solar point, the point directly opposite the sun from where you stand. If you move, the rainbow moves with you because the angle changes. Someone standing next to you is seeing light refracted by different droplets, creating a slightly different rainbow. It's unique to your position. If you take a photo of a rainbow, you're capturing the rainbow as seen from the camera's position, not necessarily the one you saw with your eyes. Rainbows are ephemeral, personal, unrepeatable. They exist only in the interaction between light, water, and your specific viewpoint. They're not objects in the sky. They're optical phenomena, patterns of light that appear and disappear depending on where you stand. And in that way, they're a little bit magic. Moments of beauty created just for you. Fact 69. There are stars that shouldn't exist. Some stars have been found with almost no heavy elements, just hydrogen and helium left over from the Big Bang. These are called population 3 stars, the first generation of stars that formed in the universe. But here's the problem. We haven't found any. We've found stars that are very old and have very low metallicity, but none that are pure hydrogen and helium. Population 3 stars should have been massive, short-lived, and should have exploded as supernovas long ago, enriching the universe with the first heavy elements. But we've never observed one. Either they're all gone, or they're hidden in regions we can't see, or our models of early star formation are wrong. It's a gap in our understanding, a missing link in the story of how the universe evolved from simple to complex. Somewhere out there, or long ago, these stars existed. They had to, but we haven't found them yet. And that absence is one of the quiet mysteries of modern astronomy. Fact. 70 your cells outnumber the stars. There are about 37 trillion cells in an average human body. That's far more than the estimated 200 billion stars in the Milky Way galaxy. In fact, there are about 185 times more cells in your body than stars in our galaxy. Each cell is a tiny machine conducting chemical reactions, producing energy, building proteins, repairing damage, dividing when needed. They work together in astonishing coordination, forming tissues, organs, systems, a body. You are not a single entity. You are a colony, a vast community of cells, each one alive in its own way, contributing to the whole. And beyond that, there are even more microbes living on and inside you. Bacteria, fungi, viruses outnumbering your own cells by about 10 to 1. You are an ecosystem, a walking planet teeming with life. And somehow, all of this complexity, all of these trillions of tiny processes adds up to consciousness, to thought, to the feeling of being you. It's miraculous, and it happens without you even noticing. Fact 71. The oldest light comes from everywhere. Cosmic microwave background radiation is the oldest light in the universe. It was released about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light could finally travel freely. Before that, the universe was a hot, dense plasma, opaque to light. But once atoms formed, light escaped, and it's been traveling ever since. That light has been stretched by the expansion of the universe, shifting from visible light into microwaves. Today, it fills the entire sky, a faint glow coming from every direction, with a temperature of about -270 degrees Celsius. It's the afterglow of the Big Bang, a snapshot of the universe in its infancy. By studying it, astronomers can learn about the early universe, its temperature, density, and composition. It's the oldest thing we can see, older than any star or galaxy. And it's everywhere surrounding us, a quiet reminder that the universe had a beginning, and we're still living in its light. Fact 72. There's a giant hexagon on Saturn at Saturn's North Pole. There's a massive hexagonal cloud pattern that's been stable for decades. Each side of the hexagon is about 14,500 kilometers long, wider than Earth's diameter. It rotates with the planet, completing one rotation every 10 hours and 39 minutes, the same as Saturn's rotation period. The hexagon is a jet stream, a fast-moving river of air, but why it forms a hexagonal shape is still not fully understood. It's likely due to the interaction between wind speeds and the planet's rotation, creating a standing wave pattern. Similar patterns can be created in laboratory experiments with rotating fluids, but seeing it on such a massive scale stable and persistent, is remarkable. The hexagon doesn't drift or change shape significantly. It's been observed since the Voyager missions in the 1980s and is still there today. It's one of the strangest and most striking features in the solar system, a geometric shape carved by wind and rotation. Proof that nature can create order in unexpected ways. Fact 73. Light has pressure. Light carries momentum, and when it strikes a surface, it exerts a tiny amount of pressure. This is called radiation pressure. It's incredibly weak, far too small to notice in everyday life. But over large distances and with enough light, it becomes significant. Solar sails, spacecraft propelled by sunlight, use radiation pressure to accelerate. The pressure from the sun's light pushes against a large reflective sail, slowly building up speed. It's a slow form of propulsion, but it requires no fuel, making it ideal for long missions. Radiation pressure also affects comets. As a comet approaches the sun, sunlight pushes on the dust and gas, creating the tail that always points away from the sun. It's not the comet's motion that shapes the tail, it's the pressure of light. Even in deep space, starlight exerts pressure, pushing on dust grains, shaping nebulae, influencing the distribution of matter. Light is not just information or energy. It's a force, subtle but real, capable of moving matter across the cosmos. Fact 74. The moon is older than we thought. Recent studies of lunar rocks brought back by Apollo missions suggest the moon may be about 85 million years older than previous estimates. That would make it around 4.51 billion years old, forming very shortly after the Earth itself. The moon is thought to have formed from debris created when a Mars-sized object called Dea collided with the early Earth. The impact ejected material into orbit, which eventually coalesced into the moon. Dating the moon precisely is difficult because its surface has been heavily processed by impacts and volcanic activity. But new techniques analyzing isotopes in lunar samples are refining the timeline. The moon's formation was one of the most important events in Earth's history. It stabilized Earth's rotation, giving us regular seasons. It created tides, which may have played a role in the development of life. And it gave us something to look at in the night sky, a companion world that's been with us almost from the beginning. It's older than the oldest rocks on Earth, a silent witness to our planet's violent birth. Fact 75. Space is expanding faster than we thought. Recent measurements of the universe's expansion rate have revealed a problem. Different methods give different answers. Observations of the cosmic microwave background suggest the universe is expanding at about 67 kilometers per second per minute. But measurements using nearby supernovas suggest it's expanding at about 74 kilometers per second per minute. That's a significant discrepancy, and it's called the Hubble tension. It suggests that either our measurements are wrong, which is unlikely given how precise they've become, or our understanding of the universe is incomplete. There might be unknown physics at play, something affecting the expansion rate that we haven't accounted for. Dark energy, the force driving the accelerated expansion, might be more complex than we thought. Or there might be new particles or forces we haven't discovered yet. The Hubble tension is one of the biggest unsolved problems in cosmology, a crack in the standard model of the universe. It's a reminder that even when we think we understand something, The universe can surprise us with contradictions that force us to look deeper. Fact 76. You are always moving backward in time for someone because of relativity. Simultaneity is relative. Events that happen at the same time for you might happen at different times for someone moving relative to you. If someone is moving away from you very quickly, the order of events can actually be reversed from their perspective. What you perceive as happening first, they might perceive as happening second. This doesn't mean time travel in the traditional sense, but it does mean that the concept of now is not universal. There's no single present moment shared by everyone in the universe. Your now is different from someone else's now if you're moving relative to each other. This is deeply strange and counterintuitive, but it's been confirmed by countless experiments. Time is not a universal river carrying everyone along at the same pace. It's personal, local, shaped by motion and gravity. The past, present, and future are not absolute. Their perspectives dependent on where you are and how fast you're moving. It's one of the most disorienting implications of relativity. The idea that time itself is flexible, negotiable, different for everyone. Fact 77. Most of your body is empty space. If you removed all the empty space from the atoms in your body, you'd be incredibly small. The nucleus of an atom occupies only about 1/1,000,000th of the atom's volume. The rest is mostly empty, with electrons occupying a cloud around the nucleus. If you compressed all the atoms in all of humanity, removing the empty space, the entire human race would fit into a cube the size of a sugar cube. All 8 billion people, compressed down to just the matter, would be roughly the size of something you could hold in your hand. Of course, this would also mean you'd weigh the same, and the density would be unimaginable. You'd collapse into a black hole immediately. But the point is that matter is mostly nothing. The solidity we experience is an illusion created by forces, not by the presence of stuff. We are mostly space, held together by fields and interactions. Patterns of energy that have learned, somehow, to think and feel and wonder about themselves. Fact 78. Stars are not eternal. Every star will die. Some, like our sun, will swell into red giants, shed their outer layers, and collapse into white dwarfs, slowly cooling over trillions of years. Larger stars will explode as supernovas, scattering their material into space and leaving behind neutron stars or black holes. But eventually, even those remnants will fade. White dwarfs will cool into black dwarfs, cold, dark, invisible objects. Neutron stars will radiate away their energy. Black holes will evaporate through Hawking radiation, a quantum process that allows them to slowly lose mass over unimaginable timescales. In the far future, tens or hundreds of trillions of years from now, all the stars will be gone. The universe will enter what's called the degenerate era, a time when no new stars form and the only objects left are dead remnants, slowly decaying. Eventually, even those will disappear, and the universe will be dark, cold, and empty. It's a distant future, almost incomprehensibly far away, but it's the fate predicted by physics. Stars, which seem eternal from our perspective, are temporary. Everything ends, even light. Fact 79. The universe might be a hologram. One of the stranger ideas in modern physics is the holographic principle. which suggests that all the information contained in a volume of space can be represented by information on the boundary of that space. In other words, the three-dimensional universe we experience might be a projection of information encoded on a two-dimensional surface. This idea comes from studying black holes and the nature of information. It's been taken seriously by physicists because it solves certain problems related to entropy and quantum gravity. If the universe is a hologram, it doesn't mean we're living in a simulation in the traditional sense. But it does mean that reality might be fundamentally different from how it appears. The depth, the volume, the three-dimensionality we take for granted might be emergent properties, patterns arising from more fundamental, lower-dimensional information. It's a deeply strange idea, one that challenges our basic intuitions about space, matter, and existence itself. And it's still being explored, tested, debated. The universe might be far stranger than we ever imagined. Fact 80, we are made of stardust. Literally, this is worth repeating because it's so profound. Every heavy element in your body, every atom heavier than hydrogen, was created inside a star. Carbon, nitrogen, oxygen, phosphorus, calcium, iron, all forged in stellar furnaces through nuclear fusion. When massive stars exploded as supernovas, they scattered these elements into space, where they eventually became part of new star systems, planets, and living organisms. You are made from the ashes of ancient stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it came from stars that lived and died long before the Earth existed. You are not separate from the cosmos. You are part of it, a temporary arrangement of stellar material given form and consciousness. And when you die, those atoms will return to the Earth, and eventually they'll become part of something else. Maybe another life, maybe a mountain, maybe a star again someday. You are stardust, and you always will be. It's not a metaphor, it's the literal truth of your existence. Fact 81. Time may not exist some. Physicists and philosophers argue that time is not a fundamental feature of the universe, but an emergent property, something that arises from deeper processes. At the quantum level, the equations don't require time to flow in one direction. They're time-symmetric, meaning they work just as well running backward as forward. The arrow of time, the sense that past is different from future, might be an illusion created by entropy, the tendency for systems to move from order to disorder. We perceive time as flowing because we remember the past and not the future, because we see things decay and not spontaneously reassemble. But at the fundamental level, the universe might be timeless. A static structure where past, present, and future all exist simultaneously. And the flow of time is just how our brains interpret it. This is called the block universe view, and it's consistent with relativity, which treats time as another dimension, no more special than space. If this is true, then everything that ever happened or will happen already exists, frozen in a four-dimensional space-time. We're just moving through it, experiencing one moment at a time, creating the illusion of flow. Fact 82. There are oceans on other moons. Several moons in our solar system have subsurfaced oceans beneath their icy shells. Europa, a moon of Jupiter, has a global ocean of liquid water beneath miles of ice. Enceladus, a moon of Saturn, has geysers shooting water into space from cracks in its surface, indicating a subsurface ocean. Titan, another moon of Saturn, has lakes and seas of liquid methane and ethane on its surface, and possibly a subsurface ocean of water beneath. These oceans are some of the most promising places to search for life beyond Earth. They're protected from radiation by ice. They have liquid water, and some, like in show signs of hydrothermal activity on their ocean floors, similar to the vents on Earth that support rich ecosystems. We don't know if life exists in these oceans, but the conditions are right. And if life evolved there, it would be independent of Earth, a second origin of life in our solar system. That would change everything. It would mean life is not unique to Earth, that the universe might be teeming with living things hidden beneath ice, swimming in oceans we've only just begun to explore. Fact 83. Your brain edits leader. Brain doesn't passively receive information from your senses. It actively constructs your experience of reality, filling in gaps, making predictions, and filtering out unnecessary details. Your blind spot, the area where the optic nerve connects to your retina, has no photoreceptors, but you don't see a black spot in your vision. Your brain fills it in with surrounding information, creating a seamless image. When you look at a scene, your eyes make rapid movements called saccades, jumping from point to point, but you don't perceive the motion. Your brain stitches the images together into a smooth, continuous experience. Even color, sound, and time are constructed. The world you perceive is a model, a best guess built by your brain from incomplete and noisy data. This means that reality, as you experience it, is not objective. It's a personal simulation tailored to help you survive, not to show you truth. Everyone's reality is slightly different, shaped by their brain's particular way of processing information. And in that sense, we all live in slightly different worlds, each one a unique interpretation of the same underlying signals. Fact 84. The deepest part of the ocean could fit Mount Everest, the Mariana Trench. The deepest part of the ocean reaches down about 11,000 meters below sea level. Mount Everest, the tallest mountain on Earth, rises about 8,800 meters above sea level. If you placed Everest at the bottom of the Mariana Trench, its peak would still be more than 2 kilometers underwater. The ocean is deeper than the mountains are tall. We've explored more of the moon's surface than the deep ocean. The pressure at the bottom of the trench is over 1,000 times atmospheric pressure at sea level, enough to crush most submarines. The temperature hovers just above freezing. There's no sunlight, no photosynthesis, just darkness, cold, and pressure. And yet, life exists there. Strange creatures adapted to conditions that would kill almost anything else. Translucent fish, giant amphipods, microbes that thrive in the most extreme environments on Earth. The deep ocean is an alien world, closer than space, but just as hostile and just as mysterious. And we've barely begun to explore it. Fact 85. You have trillions of bacterial cells. Your body is host to trillions of bacteria, fungi, viruses, and other microorganisms, collectively called the microbiome. They outnumber your own cells by about 10 to 1. They live on your skin, in your mouth, in your gut, everywhere. Most of them are harmless or even helpful. The bacteria in your gut help digest food, produce vitamins, train your immune system, and even influence your mood and behavior through chemical signals. You are not just a single organism. You are a symbiotic community, a walking ecosystem. Some of these microbes have been with your family for generations, passed from mother to child during birth and breastfeeding. They're part of your inheritance as much as your genes. When you take antibiotics, you disrupt this ecosystem, killing off both harmful and helpful bacteria. It can take months for the community to recover. Your microbiome is essential to your health, influencing everything from digestion to mental health to immune function. You're not alone in your body. You share it with trillions of tiny companions, and together you form something greater than the sum of your parts. Fact 86. Light from the sun takes millions of years to reach the surface. A photon created in the core of the sun doesn't immediately escape. The core is so dense that photons are constantly absorbed and re-emitted by atoms bouncing around in a random walk. Estimates suggest it takes anywhere from 10,000 to several million years for a photon to travel from the sun's core to its surface. Only then can it travel freely through space, reaching Earth in just 8 minutes. So the light you see from the sun was created long ago, deep inside, and has been struggling to escape ever since. It's ancient light, finally free, carrying energy that's been trapped for millennia. The sun is a slow battery, storing energy from fusion and releasing it gradually over time. Without this delay, the sun would burn much brighter and much faster, exhausting its fuel long ago. The fact that light takes so long to escape is part of what makes the sun stable, keeping it shining steadily for billions of years. Fact 87. There are sounds you've never heard. The range of human hearing is roughly 20 Hz to 20,000 Hz. Sounds below 20 Hz are called infrasound, and sounds above 20,000 Hz are called ultrasound. Many animals can hear frequencies outside this range. Elephants communicate using infrasound sounds so low that humans can't hear them, but can sometimes feel them as vibrations. Bats and dolphins use ultrasound for echolocation, emitting high-frequency clicks and listening for the echoes to navigate and hunt. Whales produce songs that travel hundreds of miles through the ocean, using low frequencies that penetrate water more effectively. The world is full of sounds you can't hear, conversations happening just beyond your perception. Even natural phenomena produce earthquakes, volcanoes, ocean waves, and storms all generate low-frequency sounds that travel through the earth and atmosphere. You're surrounded by a symphony of inaudible sound, a hidden layer of reality that other creatures navigate with ease but remains closed to you. Fact 88. The moon causes more than tides. The moon's gravitational pull doesn't just affect the oceans. It also affects the land, creating earth tides that cause the solid ground to rise and fall by about 30 centimeters twice a day. You don't notice it because everything around you moves together, but the earth itself is flexing, bending under the moon's influence. The moon also affects the atmosphere, creating atmospheric tides, though these are much weaker than ocean tides. Over long timescales, the moon has had a profound effect on Earth. It stabilizes our axial tilt, preventing wild swings in climate that would make life difficult. It slows Earth's rotation through tidal friction, lengthening our days. Billions of years ago, a day on Earth was only about 6 hours long. The moon's influence has gradually stretched it to 24 hours, and it will continue to lengthen, though very slowly. The moon is not just a passive companion. It shapes our world, our climate, our days, our very existence, quietly exerting its pull, keeping us stable, keeping us spinning at a pace that allows life to thrive. Fact 89. You are luminous, your body emits light. Not much, and not in the visible spectrum for the most part, but you glow. This is called bioluminescence, but in humans, it's more accurately described as metabolic light emission. Chemical reactions in your cells produce photons as a byproduct. The glow is about 1,000 times weaker than what your eyes can detect, but it's there, measurable with sensitive equipment. You glow brightest in the late afternoon and dimmest in the early morning, following your metabolic rhythms. Your face glows more than the rest of your body because it has higher metabolic activity and more blood flow. You are not just matter. You are energy, constantly radiating, emitting light into the darkness, a faint beacon of biological activity. Every living thing emits light in this way, a quiet signal that life is happening, that chemical reactions are turning fuel into motion, thought, warmth, and light. You shine even if no one can see it. Fact 90. The universe is flat. When cosmologists say the universe is flat, they don't mean it's a flat sheet. They mean that the overall geometry of space is flat. Following Euclidean geometry, parallel lines stay parallel. The angles of a triangle add up to 180 degrees. The alternative would be a curved universe, either positively curved like a sphere where parallel lines eventually converge, or negatively curved like a saddle where parallel lines diverge. Measurements of the cosmic microwave background suggest the universe is flat or very close to it. This has implications for the universe's fate. A flat universe will expand forever, slowing down but never stopping, eventually reaching a state of maximum entropy where no energy remains to do work. A positively curved universe might eventually collapse back in a big crunch. A negatively curved universe would also expand forever, but more rapidly. Current data favors flatness, which means the universe will continue expanding, cooling and dimming until nothing remains but cold, dark, empty space. It's not a dramatic end, but a slow fade. The ultimate stillness. Fact 91. You shed constantly. You lose about 30 to 40,000 skin cells every minute. That's roughly 50 million cells per day. Most of the dust in your home is dead skin cells. When you walk, sit, or move, you leave a trail of cellular debris. Your skin completely replaces itself about every 28 to 30 days, cycling through generations of cells, constantly renewing. This shedding is necessary. Skin cells on the surface are dead, flattened, filled with keratin for protection. They're exposed to damage from sunlight, friction, and environmental wear. So your body continuously replaces them, pushing new cells up from deeper layers while shedding the old ones. You are not static. You are in constant flux, a dynamic system, always rebuilding, always renewing. The you of a month ago is gone, replaced cell by cell, molecule by molecule, and yet the pattern remains. You persist through change, an identity maintained across countless small transformations. a continuity of form even as the substance flows away. Fact 92. The Sun will one day swallow the Earth in about 5 billion years. The Sun will exhaust its hydrogen fuel and begin fusing helium in its core. This will cause it to expand into a red giant, growing so large that its outer layers will reach beyond Earth's current orbit. Mercury and Venus will definitely be consumed. Earth might be as well, or it might barely escape, depending on how much mass the Sun loses during its expansion. Either way, Earth will be sterilized long before that. As the Sun grows brighter, the oceans will boil away, the atmosphere will be stripped, and the surface will become a molten hellscape. Life will be impossible. Any survivors, if humanity still exists in some form, will have had to leave long ago, finding new homes around other stars. The Sun, which has nurtured life for billions of years, will eventually destroy the world it created. It's not malicious. It's just the natural life cycle of a star. Everything ends, even the Sun, even the Earth, and in their ending, they'll create new elements, new dust, new possibilities for future worlds orbiting future stars. Fact 90. 3. You are breathing history. Every breath you take contains atoms that have been part of countless other things. Some of the oxygen molecules in your lungs were once breathed by dinosaurs, by ancient humans, by trees that lived and died millennia ago. The atmosphere mixes over time, circulating gases around the planet. So every breath is a sample of the entire atmosphere's history. You inhale molecules that were once part of the ocean, evaporated by the Sun, lifted into clouds, rained down on mountains, absorbed by plants, released again. You breathe in particles from volcanic eruptions, forest fires, the breath of every person who ever lived. The air is a commons, shared by all life, past and present. When you exhale, you release carbon dioxide, water vapor, and trace gases that will disperse, mix, and eventually be breathed by someone else, somewhere else, someday. You are connected to everything that breathes, linked through the air, through the invisible exchange of molecules, through the simple act of breathing. Every inhale is a reunion with history. Every exhale is a gift to the future. Fact 94. Space bends light. Gravity doesn't just pull on matter. It bends space-time itself, and light follows those curves. This is called gravitational lensing. When light from a distant galaxy passes near a massive object, like another galaxy or a cluster of galaxies, the light's path curves, creating distorted, magnified, or multiple images. Sometimes you'll see a distant galaxy smeared into an arc or a ring around a closer galaxy. This isn't an optical illusion. It's the fabric of space itself, being warped by mass and light dutifully following the curves. Einstein predicted this in his theory of general relativity, and it was first confirmed during a solar eclipse in 1919, when stars near the Sun appeared shifted from their normal positions because the Sun's gravity bent their light. Today, astronomers use gravitational lensing as a tool, studying the distortions to learn about dark matter, map the distribution of mass in galaxy clusters, and even discover distant galaxies that would otherwise be too faint to see. Gravity shapes not just the motion of objects, but the path of light itself, turning the universe into a hall of mirrors. Fact 95. You are quantum at the smallest scales. You are not a solid deterministic object. You are a collection of quantum particles, each existing in states of probability until measured or interacted with. Electrons in your atoms don't have fixed positions. They exist as clouds of probability, more likely to be in some places than others. The bonds between atoms, the chemistry that makes life possible, are governed by quantum mechanics. Photosynthesis, the process plants use to turn sunlight into energy, relies on quantum effects. Even your sense of smell may involve quantum tunneling, where molecules pass through barriers they shouldn't classically be able to cross. You are made of quantum stuff, and at every moment, countless quantum processes are occurring in your body, enabling thought, metabolism, sensation, life. You are a quantum machine, a system where uncertainty and probability are not bugs but features, essential to your existence. The universe is strange at the deepest level, and so are you. You can't escape it. You're part of it, built from it, shaped by it. Fact 96. The stars you see are mostly dead when you look at the night sky. Many of the stars you see no longer exist. They've already burned out, exploded, or collapsed, but their light is still traveling toward us. Light takes time to travel, so the farther away a star is, the older the light you're seeing. A star 100 light-years away shows you what it looked like 100 years ago. A star 10,000 light-years away shows you its appearance from 10,000 years ago. Some stars have already ended their lives, but we won't know for thousands or millions of years, not until their final light reaches us. In a sense, the night sky is a graveyard, full of ghosts, stars that once were but are no more, their light the only remaining evidence of their existence. It's melancholy and beautiful at the same time. The universe preserves memory in light, carrying the image of stars across vast distances and timescales, allowing us to see the past, to witness what was, even after the thing itself is gone. Fact 97. The universe may have no purpose. This isn't a fact in the scientific sense, but it's worth considering. The universe shows no signs of being designed for us or for any purpose. It's vast, mostly empty, and indifferent. Stars burn and die without audience. Galaxies collide without meaning. The laws of physics operate without intent, simply following mathematical rules, consequences of how energy and matter behave. There's no evidence of a cosmic plan, no message written in the stars, no design that points to purpose. This can feel bleak, but it can also be liberating. If the universe has no inherent purpose, then purpose is something we create. Meaning is something we give, not something we find. We are free to decide what matters, what's worth caring about, what we want to do with the brief time we have. The universe doesn't care, but we do, and that's enough. Purpose doesn't need to come from the cosmos. It can come from us, from connection, from love, from curiosity, from the simple act of existing and choosing to make something of it. Fact 98. You will become stardust again when you die. Your atoms will return to the earth, dispersing slowly over time. They'll be absorbed by plants, eaten by animals, washed into the ocean, lifted into the atmosphere. Over millions or billions of years, some of those atoms might be incorporated into new stars when the sun dies and its material mixes with interstellar gas. Your carbon might become part of a new planet. Your oxygen might float in a nebula. Your iron might end up in the core of a distant star. You came from stars, and you'll return to them eventually, in some form. It's a cycle that's been happening since the universe began. Matter flowing from stars to planets to life and back again, endlessly recycling, endlessly transforming. You are temporary, but the atoms that make you are not. They're ancient, and they'll persist long after you're gone, taking new forms, becoming part of new stories, drifting through the cosmos, carried by processes too large and too slow for any single life to comprehend. You will dissolve, but in dissolving, you'll become part of everything. Fact 99. The present is all we have, the past is gone, existing only as memory and evidence. The future hasn't happened yet, existing only as possibility and prediction. The only thing that's real right now is this moment. And even as you read this, it's already becoming the past, replaced by the next moment and the next. Time flows in one direction, carrying us forward whether we're ready or not. We can't go back. We can't skip ahead. All we have is now, this brief instant where experience happens, where choice exists, where life unfolds. It's easy to lose sight of this, to spend time dwelling on what was or worrying about what might be. But the universe doesn't exist in the past or future. It exists now, and so do you. This moment, however ordinary or extraordinary, is the only one you'll ever truly inhabit. Everything else is abstraction. The present is where life happens, where beauty exists, where connection forms. It's fleeting, always slipping away, but it's also always here, always arriving, always new. The present is a gift, and it's the only one the universe gives repeatedly. Fact 100. You exist out of all the possible arrangements of matter, out of all the ways atoms could have come together. They came together in a way that creates you. You are conscious, aware, able to wonder about your own existence. The odds against this are staggering. The right atoms had to be in the right place at the right time. The Earth had to form in the habitable zone of a stable star. Life had to emerge from chemistry. Evolution had to stumble through billions of years of trial and error, leading eventually to humans, and then to your specific lineage. Your parents, their parents, stretching back through an unbroken chain to the first living cell. If any one of countless events had gone differently, you wouldn't be here. And yet, here you are, existing, thinking, feeling, aware of yourself and the universe. It's the most fundamental fact of all, the one that makes everything else possible. You exist, and in existing, you are part of the universe's way of knowing itself, of experiencing itself, of wondering about itself. You are stardust that learned to think, atoms that learned to feel, matter that learned to care. And for a brief moment, in the vast expanse of time and space, you get to be here, part of this strange, beautiful, mysterious cosmos. That's not nothing, that's everything. And that brings us to the end. 100 facts about the universe, each one a small window into the vastness, the strangeness, the quiet beauty of existence. Some of these facts are humbling, reminding us how small we are. Others are empowering, showing us that we're connected to everything, made from the same stuff as stars, following the same laws, part of the same story. The universe is under no obligation to make sense to us. and yet we keep trying to understand it. We measure, we calculate, we observe, we wonder, and in that wondering, we find meaning not because the universe gives it to us, but because we create it through the act of paying attention. So tonight, as you drift towards sleep, remember that you're floating on a planet that's spinning through space, orbiting a star that's one of billions, in a galaxy that's one of trillions, in a universe that may be infinite. You're made of ancient atoms, recycled through countless forms, temporarily arranged into something that can think and feel and dream. You are part of this cosmos, not separate from it. And for this brief moment, you get to witness it, to experience it, to be amazed by it. Sleep well, knowing that the universe is vast, beautiful, and stranger than we can imagine. And you're here, right now, part of it all. Thanks for listening to the Sleep Labs. Until next time, keep wondering, keep dreaming, and remember that you are quite literally made of stars.